Differentiation is the process of finding the derivative of a function which represent the rate of change or the slope of the function at any point. Two keys technique are: first, the power rule. For y equals to x to the power of n, the derivative is dy over dx equals to n multiplied with x to the power of n minus 1. Example, if y equals to s to the power of 3, then the dy over dx is equal 3x to the power of 2. The chain rule, used for composite function. If y equals to f gx, then dy over dx will equal f derivative gx constant multiplied with derivative of gx. Example, for y equals to sin 2x, the derivative is 2, coming from derivative of gx. Cos coming from derivative of sin, and 2x is constant. Okay, let's solve the derivative of this question. So first, rewrite as y equals to 2 cosec 4x plus minus 2 and the power of 5. And we apply a chain rule, which is we need to derivative of the outer function, which is 10 cosec 4x minus 2. It coming from because 2 inside of that cosec 4x minus 2 is constant. So we just derivative, we make cosec 4x minus 2 as a u constant. So that's why we get 10, because 5 multiplied with 2 we got 10, and 5 minus 1 we get 4. Next we will multiply by the derivative of any function, which is the cosec 4x minus 2, which is equal negative cosec 4x minus 2 cot 4x minus 2 multiply with 4. And 4 is coming from 4x derivative of 4x minus 2. And the final answer is dy over dx equal negative 14, because 4 this 4 we multiply with 10. We got negative 4, and negative is coming from negative cosec. And cosec the power of 5, because this cosec is 1, and we will multiply with cosec 4. So we will get cosec 5, 4x minus 2, and cot 4x minus 2. So let's do the part B question. In this question, we see the divide. So automatically, we will use the quotient rule. So first, let's u equals to 3x to the power of 3 minus 1, and v equals to cos 2x plus 4. It coming from this. The up here is the u, and the below there is the v. So we do the derivative here, and we get u prime equals to 9x to the power of 2, and v prime equals to negative 2 sin 2 plus 4. So this is the final answer after you put all the word follow the quotient rule. Y is plus because the negative 2 will multiply with the minus, so you get the plus.
To do is we need to apply the chain rule. Okay, so for this one, what we can do is we can apply product rule, which is okay. So what is the u and what is the v? So u equals to v divide and what is the v? V equals to divide c 2x minus 3 u prime equals to, if we derivative the y, we will get dy over dx. So v prime. So if we get d over dx, since you also know it is equal to cos. So cos 2x minus 3, and we derivative the inside. This is 2x, and if we derivative it, it will become 2. Okay, so this is the u, v, and u prime and v prime. So what we're gonna do? We're gonna conclude this all into one. Okay, so you use this one, u y v prime 1 2 cos u v prime plus this v sin v prime. Okay, so after this we will rearrange a bit. So this is the final answer for this one. We substitute the power with u, but if we substitute it with u, we have to also times it with du dx, like this. Okay, so first e of u du dx. U is equals to 3y squared. So we have to do the derivative because we want to find the du dx. So du dx is equal to 2 divided by 1, so it times 3 and equal 6y. So the y, if we derivative it, it will become dy over dx. Okay. So if we just substitute into this one, so it will become d squared minus 6y by dx. Okay, so the next term is ln 5x. So as we know, ln fx also equals to 1 over fx times f prime x. What are we going to do? We substitute the 5x into just fx, so 5x. So the f prime x, we just do another derivative equals to 5. Okay, so we use this, we substitute into this, it will become 1 over 5x times 5. So we put it here. So we get 5 over 5x. Okay, so 6x. We get 6. After that, after we done all the term, we just combine it and we get like this. So okay, this one 5 over 5x, we can 1 over x. So this one we can put it this side. So this dy dx and this term also have dy dx, so we can factorize it. So after we bring the multiply and divide with the other side, this will become the last answer.
What is linear approximation? Linear approximation is a method used in calculus to estimate the value of the function near a point using the tangent line at that point. From the question, 2 over 4 root 80.77 minus square root 80.77. The linear approximation near a point x equal to a is fx almost equal fa plus f prime a multiply x minus a. We have two functions. Fx, the first fx is 2 over x 1 the power of 1 over 4, and gx x power 1 over 2 will approximate both at the convenient value close to 80.77. The closest easy value is a equal to 81. Step 2. Compute derivative h prime x. We differentiate hx 2x power of minus negative 1 over 4 minus x power 1 over 2. H prime x we will differentiate and we get 2 multiply 1 and negative 1 over 4 x negative 5 over 4 minus 1 over 2 x the power of negative 1 over 2, and we will get negative 1 over 2x the power of negative 5 over 4 minus 1 over 2x the power of negative 1 over 2. At 81, we just use 81 at x, so 81 the power of negative 5 over 4 equal to 3 power of 4 power of negative 5 over 4. We will get 3 the power of negative 5, so we get 1 over 243. So next, 81 the power of negative 1 over 2, we will get 1 over square root 81, so we get 1 over 9. Lastly, h prime 81, we just transfer 1 over 243 and 1 over 9 from into our first derivative function, that is h prime. Lastly, we will get negative 14 over 243, and we change it to the to this number, we get negative 0.0576. Step 3. Linear approximation. We just transfer all our value into the formula. So h80.77 almost equal h81 plus h prime 81 multiply 80.77 minus 81, and we will get negative 8.3201. And the final answer, we must take 3 decimal places. So the final answer is negative 8.320.
To wrap up, implicit differentiation lets you find dy dx when y is mixed with x. Just differentiate both sides, use the chain rule on y terms, and solve for dy dx. Remember, treat y as a function of x every time. This is too powerful for tricky equation in calculus. Try practicing it with more examples to master it.